Hello, pre-calculus students. We are going to solve an example here that deals with trigonometric functions. And this time we're going to solve for all solutions of theta, still in the same interval. But notice here we have something a little bit different, 2 theta. Okay. So first, let's get theta out of there, out of the cosine method, the cosine function. And let's look at the unit circle. Where is, you always want to ask yourself, where is cosine equal to 1/2? So we're going to treat 2 theta here as a single variable, even though it's a constant in a variable. But let's look at our unit circle. That wasn't very circular of me, but hopefully you get the idea that this is supposed to be, let me try that again. This is supposed to be a unit circle. Let's try that again. So cosine is equal to 1/2, and at this location here, remember this point is 1/2 root 3 over 2, and down here this is 1/2 negative root 3 over 2. Right? And the angles at those particular spots, this is pi over 3, and down here this is 5 pi over 3. Okay? So we know that there are 2 solutions to this problem so far, at least for theta. For 2 theta. So we know that 2 theta is equal to pi over 3, and that 2 theta is equal to 5 pi over 3. Okay. So we have to, but remember we're solving for theta. We're not solving for 2 theta. So we divide both sides by 2, and we get that theta is equal to pi over 6, and that theta is equal to 5 pi over 6. Now, you would think that these are the only 2 answers, but that would be incorrect, and let me show you why. Alright, so let us consider the graphical view of this, just as we did before. This time, instead of graphing cosine theta, I am going to graph cosine 2 theta. Okay? So this graph here is the graph of f of x equals cosine 2 theta, or f of theta is equal to cosine 2 theta. So what that means is there's a horizontal shrink on everything. And so this point here would be only pi, not 2 pi. And this point here would actually be 2 pi. Okay. Now, thinking about where does the line, how many solutions there are. Before we said that there were 2 solutions. Now there are 1, 2, 3, and 4 solutions. Okay? And we know that pi over 6 has got to be one of those solutions. This is pi over 6. Right? And then what we also need to understand is we also know that right here 5 pi over 6 is one of those solutions. Okay? So how are we supposed to get the other 2? Well, it's not too difficult to figure that out. We know that the period, instead of being 2 pi, it's going to be 2 pi over 2, or pi. So we just add the period to each one of these solutions. In other words, from pi over 6, if we were to add pi units to it, we would get to this other point of intersection. And then from 5 pi over 6, if we were to add pi to it as well, we would also get the 4th solution here. So the remaining solutions here would be theta equals to pi over 6 plus pi, right, because we're adding the period, and theta would also be equal to 5 pi over 6 plus pi. So that would give us our solutions as 7 pi over 6 and 11 pi over 6. So we have 4 solutions to this problem. 7 pi over 6, 11 pi over 6, 5 pi over 6, and pi over 6. Okay. So to recap, because the period is different, because you have a shrink right here, a shrink horizontally to 1/2 of its original size, the waves are going to repeat more often. So you're going to have twice as many solutions as you did before between in the interval of 0 to 2 pi. So some questions you should ask yourself: what if this number in here was 3 theta? How many solutions would you have then? What if this number in here was 1/3 theta or 1 theta? I'm sorry, or 1/2 theta. How many solutions would you have then, and what would they be? All right, so always try to stretch yourself